Hi, I'm Chris Mather, and I'm here to talk about the Richard Desich SMART Commercialization Center for Microsystems on the campus of Lorain County Community College. It's a very, very unique resource for the community, and it's very similar in some ways. If you've watched the previous video on Shared Resource Center at the Tech Belt Energy Innovation Center out in Warren, similar concepts in that you do a multi-user shared resource center for a number of reasons. One, it's a great use of public and philanthropic dollars for economic development, because in these centers you take some equipment and make it available to entrepreneurs and companies, and often it's equipment that they wouldn't normally have easy access to, and you make it so that companies can afford to do it. So the entrepreneurial companies get access to equipment that they otherwise really couldn't even get at or afford. But even larger companies like Rockwell Automation and Parker Hannifin have found that in a good business decision, it makes sense to have this equipment sit somewhere else as opposed to on their campus where they have to maintain it. And then from an economic development point of view, you have lots of local, state, and even national advantages. One is it's what we call stickiness, so that things want to stay here. So if you've done your development at Lorain County Community College, you're likely to want to stay in Northeast Ohio because you've gotten used to having that resource. So it tends to keep companies here on a local basis. It also develops some capacity in certain technology areas. So if, in our case, this is in an area called MEMS sensors, which I'll explain a little bit, but it means that this region starts to develop an expertise, and you start to have what's called clustering, where companies start to come together. So a company is doing MEMS development, while another company sees how well they're doing, and they realize that there's good reasons to be together. And the last thing is it makes our geographical area more attractive for further development. So before I get into the center itself, let's talk a little bit about Lorain County Community College. This is a resource in this region that's pretty amazing. Lorain County is likely the best community college in the entire U.S. in terms of economic development. And a lot of community colleges are focused on economic development. And it sounds braggy, but I think we can easily say that Lorain County is unique and just different from any other community college in the country. For example, we've got an on-campus technology incubator. Not many community colleges have that, called Glide. But tied with that, we actually have an early stage pre-venture seed fund called the Innovation Fund, which is so different and so impactful that Lorain County Community College has been asked and funded by the Kauffman Foundation to bring that model nationally to see if it can help community colleges, help local companies and local economies grow. We have a MIT-supported Fab Lab, which brings physical creation tools into the hands of the every person. And the idea was originally pushed for third world countries, and the people at MIT realized that it also could work well in local communities, and it's worked very well for us. We also have an independent sensor testing facility here right in Lorain County Community College, and if you need to test a sensor in a certain area, we're the only North American independent center. So a very, very different place, and a great place for the SMART Center. So what are MEMS? MEMS stands for Micro-Electromechanical Systems, and it turns out you guys deal with MEMS every single day. If you hear the term Microsystems, it's also the case. And I like to think of it as, if you think of the Pentium chip in your laptop, that's a chip that thinks. It doesn't do a lot physically, but these are chips that actually physically do something, and they're used the same kind of integrated circuit technology that you use for making Pentium chips, but they're used to physically make something. So typically they're sensors or actuators. So the ones you deal with every day, if you came here by car, your car has at least 15 or 16 MEMS sensors, because they're the sensors that do the airbag detection. So if you've ever been in a car crash at 5 miles an hour, your airbag doesn't explode into your face, which I've been told is not a great experience. On the other hand, if you have that same crash at 20 miles an hour, you want that airbag going off, and those sensors are actually smart enough to do that, and they're what are called little MEMS accelerometers. All of you have a cell phone in the room, I'm sure, and the chip that decides when you turn your phone this way versus this way is a MEMS gyroscope. that just detects that, and the microphones in your cell phones or MEMS. And one of the reasons why the microphones are MEMS is because cell phones, as you know, have gotten smaller and smaller and smaller, but the quality of those microphones have gotten better and better and better, and they have to keep lowering the cost. And so MEMS give you great performance and with small physical size at low cost. If any of you have a Wii controller, if you've ever used that device, you know, you can move around, and it's amazing what a Wii controller can do with those games. And that chip has to be low cost because those controllers are not very expensive. They have to be robust because all of you know what you do with those controllers when you're done with them. They end up on the floor, and so they have to be very, very robust, and they have to have great performance. So really, we've seen a boom in MEMS chips. They're everywhere, and it's going to be proliferating. It's a very, very high growth market. So the Smart Center basics is that we are a shared resource center, which means we have equipment available for various people. We are focused on commercializing MEMS and sensors. And one of the things that we don't do is we don't actually make the chips, and I'll get down to how that works in a second, but we really work on the back end. So once you've created the chips, we help you get them to market. So we have a wide range of software and hardware focused on the packaging and inspection of those MEMS chips available. We opened up in a facility in Lorain County Community College in September of 2011, and we'll be moving to a new 47,000 square foot facility that opens up in 2013. In fact, I'll go back, because if you look at this wafer at the bottom, that's a large wafer. Typically the wafers that MEMS chips come on, I ran a small MEMS company, and I could get maybe 300 chips on a 4-inch wafer about the size of a CD. And literally this, if you can see the little waffle kind of pattern, each one of those squares is a chip. And eventually they're going to cut those, so that's going to turn in this case, it's a very large wafer. It's probably 1,000 chips on that wafer. And typically what happens is, so you work on what's called the front end. So you're going to do some design. You're going to think of, what does the chip that I want to use do? So for example, if it's an accelerometer, it has to detect how fast something speeds up or slows down. And there's various ways to do that. In the case of my company, we actually could generate a certain kind of infrared non-visible light so that we had to have a chip that was working in a vacuum. So you do that design, and then you do a lot of what's called co-design, which means you do some of that design in software because it's expensive to go through the process. But the third piece of this, where you see wafer foundry, that is a very, very key part. So that's where they take the concept and they actually go through, and it's people in the little bunny suits like you saw on the previous slide, where they're making a wafer full of chips, and the output of that wafer foundry is what we treat as our raw material. Usually you get that done, if you're an early stage company, you're going to get that done at a university. So for example, within drive time of Northeast Ohio, you've got Case Western Reserve has a foundry, Ohio State has a foundry, bigger and frankly, in some cases more capable foundries at Penn State, at Purdue, at University of Michigan, at Northwestern, and at Cornell. So those are all within 1 day's drive. So we don't do that at Lorain County Community College. We treat those people as our partners, because once they get done making this chip, so now this wafer, they've got a wafer with a couple of 100 chips on it, they kind of lose interest. And that's why a place like a community college, Lorain County Community College, works with them, and then we take and we package, assemble, test, and evaluate those chips. So the things that drive us is that those back-end processes, the packaging, are ones that are uninteresting to the typical research universities like Case, Ohio State, Purdue, but they're critical path. I mean, if you can't package it and you can't put it in a way that it's going to fit in the Wii controller, it just won't work. Right now, most of the methods to do this are pretty costly, they're slow, and they're problematic, but companies are hesitant to buy the equipment because the return on investment, or ROI, which I'm sure you've seen in some of these other presentations, can be pretty poor. So that you're maybe in your first chip, you're not going to get that money back. So the shared facilities really allow us to kind of break that, that cycle, because the equipment's available at very, very low price. And there's very little, I know you've had some discussions in these presentations about intellectual property. You have very little intellectual property issues because the actual way you design that chip on that wafer, you own that, so that's easy. But in the back end, and how you package it is really not typically an intellectual property issue, so you're pretty protected. So today we're in 1,800 square foot, what's called the Class 10,000 facility. And Class 10,000 actually just refers to how clean the air is. So in a cubic foot of air, it says how many particles that are considered to be rogue that you really don't want in there, so particles of contamination. So there will be 10,000 per cubic foot of air, which if you think about that, considering how many molecules it is, that's a pretty clean environment. But relative to this industry, this is a relatively non-clean environment, in that typically the chips are fabricated in a Class 10, which means 10 particles per cubic foot of air, or even a Class 1 type facility, which means 1 rogue particle per cubic foot of air, which is just amazing, probably the cleanest environment you can think of on Earth. In our case, since the chips are already made, we can be a little bit dirtier, but what we've realized is that for our students, which is not only students from Lorain County Community College, but ones from Case and Cleveland State, if they have been in a clean room, if they understand what you have to do, and if you saw the previous picture, you have to put on something on your head, and you've got a coat, and you've got gloves, there are procedures you have to follow. If they have been in a clean room, their resume goes into a different pile. So that matters when it comes to jobs. And we've basically divided the Smart Center into an area for chip packaging, another area for surface mount, which actually puts the chips on boards, reliability testing, so we're going to stress the chips and make sure that they work, and then a whole section for inspection and characterization, because what you want to do is make the chip, package it, stress it, and then look at it, and then do it again a few times. This is a picture looking through the window of the Smart Center, because realize since it's a Class 10,000 environment, you have to go through a procedure to enter the room. So it is a little bit of a strange picture, but on the right you can see some of the reliability equipment, and it's a very lavish type environment. Now this is 1,800 square feet. Our new building will have over 10,000 square feet of various kinds of clean rooms, actually in some as low as Class 100, because we'll start to do some packaging that's a little bit different, that's a little more focused at the chip level. So what do you do? And I won't go through all of these. People that are in this business, they start looking at this list of equipment and oohing and eyeing. In this case, what you want to do is you start off with this wafer. So think of a CD that looks like, and I tell people think of an Eggo waffle, whereas on an Eggo waffle you'll get about 10 chips. So you've got basically dicing lanes. So think of they go this way and they go this way, and we literally cut that wafer in this direction and in that direction, so that you end up with a few hundred chips, and they're put on an adhesive so they don't go flying all over the place. So that's what the die saw is. It literally is a saw, a high precision saw that can cut these wafers, and they can literally, in some cases, only cut partially into this very, very thin. Think of a CD. We're only going to cut a third of the way through the CD. Then we have some cases where we want to just manage the chips, so we have washing stations. Die sorters, basically the washing station is a dishwasher. A die bonder says you've got that little chip, so the little chip is called a die, and that actually lets you attach other things to that die. And then you have a very important process called wire bonding, because you have to have this chip. If you've ever wondered how do you make a connection, your car has all these chips, but they use fairly large wires. How do you get to the real world? Well, you do that through wire bonding. So you take very, very thin, typically gold wire, you connect it to somewhere on the chip, and then you connect it to the outside world where you can connect it to the wiring harness of a car, for example. So all of these things are really set up for where do you start with a Microsystems chip. And you'll notice at the bottom you'll see a coater. So that's a coating called Parylene, which is a very unique coating that can basically take those chips and make sure that they work in a wet environment. So you might think for hospital applications would be, or any outdoor applications, your chips in your cell phones are most likely coated, although if you drop your cell phone in the water, it seems like they definitely want to sell you a new one. So this is all resources that are for taking that wafer that's full of a couple hundred chips and getting it into hundreds of individual chips that are now ready to be implemented in some way. The next thing we do is we do some reliability testing. So they have the ability to stress the chip. These are usually physical kind of conditions, so we can adjust temperature, pressure, humidity, and in one case we've got, if you notice on the lower left, that device is has a UV light source, so we have the ability to do accelerated sun testing. So if you want to say what happens if this product is out in the elements, so we can give you 20 years of sunlight in a couple of days, the equivalent of UV radiation. At this point in the lab, you don't have to be working on Microsystems. As long as whatever you're working on fits in our chambers and our products, we can do computer chips, we can do MEMS chips, and we can do paint chips as well. As long as it's a safe environment, it's not a problem. So that we've seen a lot of companies using our facilities. DuPont is testing materials in our facilities that aren't necessarily MEMS chips. Well, the next thing is after you've stressed it, you want to look at it. And we have a number of different tools. We try not to duplicate tools that are available in other places in the country or even in the area. So for example, Case Western has a tremendous imaging lab where they can use what are called atomic force microscopes and scanning electron microscopes. We don't have those tools because they're available locally. What we do have, if you notice on the lower right, is a thing called an acoustic microscope, which is really like a CAT scan for a chip. So if you imagine that if you have this tiny, tiny chip, which is literally less than a quarter-inch square, and you may have 6 layers of different things going on, and you have a suspicion that between layer 3 and 4, you're getting delamination, so the things are separating. Those other tools, as high resolution as they are, I mean, atomic force microscope can literally nearly see atoms. You still can't see that because it's in layers. Well, the acoustic microscope uses a CAT scanning type technique where we can show you what's happening only between layers 3 and 4, so you can do some evaluation. So this equipment from an inspection point of view is very, very focused on the customers that we work with. We do have some thermal imaging, which is not really the most expensive equipment that we have, but they work for a particular application. We have a company that's working with us in a solar concentrator, which basically takes lots and lots of solar energy, uses mirrors to concentrate it in. So rather than a big solar panel, you have big mirrors. And in their little structure, they know what's supposed to be hot and what's not. And so they can look with a thermal imaging camera and very quickly decide if the chip is working the way it's supposed to or not. So that's an application where a lot of other people have found that just for testing, just knowing where the heat is and where the heat is not in an electronic assembly makes a big difference. Then the last area that we have is we actually have some of that co-design software, which is available for rent. So to give you an example of some of this stuff, SolidWorks, for example, any of you that are going into engineering, and we hope a lot of you do, you'll learn that in your freshman and sophomore year. Every engineer does now. But MEMS Pro, which is another software package, is a package that's set up for designing MEMS chips. It's very, very specific software, and it's over $100,000 to buy the package. So even a larger company might hesitate before buying that. We give them the opportunity to do a little bit of design with that software, but and also to kind of evaluate if they need it. So in some cases, they use it for what they needed, and it's a better way for them to get access to that software. In other cases, and certainly SoftMems is the company that makes that software, hopes that somebody looks and says, we need to have that, and so they talk their bosses into spending $100,000 on the software. We have priced the lab time extremely, extremely cheaply. Now, as high school students, this may not look cheap to you, but trust me, between $60 and $150 to access this kind of equipment is extremely low cost. If anything, we've been told that maybe we should raise the prices because it's too low cost. But we really want to make it available to entrepreneurs and small companies as well as large companies. The software access is priced at $75 an hour. So when we put this lab together, we actually had a great quote from the guy who runs the MEMS Foundry, so that foundry partner at Ohio State University, and he said this might be the best lab of its type in the country. And I asked him if I could quote him, and he said, well, you can, but you have to say it's one of the best, mainly because he didn't want to get on the wrong side of the people at Georgia Tech, who are great from a research point of view in this MEMS packaging area. And from Lorain County Community College's point of view, we're great with being in the same sentence as Georgia Tech. But it's very, very low priced, and it's one of the best labs of its type in the country. The kind of projects that we work on. When we got our first grant, the state dollars were used to really fund this center the first time, so it's kind of your tax dollars, part of the Ohio Third Frontier. And it was suggested that we work with 4 specific projects, so that's what we did. And there are 4 different projects, which I think really shows how not only Microsystems pervade our lives, but also the different kind of companies that can take advantage of such a center. So the first one that you see there, Beckett, is a very, very old company that makes boilers and water heaters for commercial and residential applications. Well, they found out for their hot water boilers that if they can use a MEMS chip to manage the outgassing and use it as a part of the control system, they can get 10 to 15% better efficiency from their boilers, which results in real cost savings. The second one is a company called Asense. It's a small entrepreneurial company with a very well-known Cleveland entrepreneur, and he's developed an acetylene sensor that goes in a transformer of for utilities. And it turns out when transformers start to arc, they give off acetylene gas, and after they arc, eventually transformers will go on fire, and that means your power is going to go out. And this little sensor can actually detect that the transformer is giving off acetylene, therefore it's going to begin to arc, and they can selectively repair that transformer before you have a fire and the resulting outage. Greenfield Solar is the solar concentrator technology from NASA that I mentioned. And the last one is a biomedical sensor, which is a big use for MEMS. Because you think about these chips have to be very, very small, very, very reliable, very low power use. That's a great fit of characteristics that fit for medical applications. So in the case of Case Western Reserve University, it's a transdermal sensor to monitor various metabolic functions. Other projects, I won't go through all of these, but you can look at them on screen. We have a wide range of small companies like Primaris and GreenVolts and Mobile Awareness and Inspectra Sensors, but then also some very large companies like Bendix, Parker Hannifin, and DuPont using the center. And you can see it's a wide range. In some cases, they're making sensors, usually using MEMS chips. In other cases, they're doing paint and coatings, reliability type testing, or just DuPont, which is doing general materials reliability because of the tools that we have. We also work as a research partner. We are not a research university, and what that means is that we don't typically go for research grants because the professors at a community college are typically there to teach, not to teach and do research. A place like Case Western, very large, nationally known research university, but large research budgets at the University of Akron, Youngstown State, Cleveland State, and Kent State University here locally. So we are trying to work with those, but we're a great partner because if somebody at Case puts in for a grant for doing biomedical engineering research, and they have Lorain County Community College on their grant application, the chances are they have better odds of getting the grant, and we provide a valuable resource that they don't have access to any other way. And I mentioned that we are investing in the future. We are now in an 1,800 square foot lab plus an 1,800 square foot office facility. We are moving to a total of 47,000 square feet. It's a major, major development at Lorain County Community College. I think it goes back to us being just different and certainly the best community college in terms of economic development. It's being tied into our Entrepreneurial Innovation Center, which is a building that's dedicated to entrepreneurship and small companies. So there's very, very little, if any, teaching that goes on in that building. It'll be connected, as you can see in the picture, to a via Skybridge, because we do live in Northeast Ohio and we do get a little bit of snow, to this new center, which the larger, taller part of the building that you see will be focused on lab space for companies. So companies can take up residence at Lorain County Community College. And then the lower part that's perpendicular is actually the various labs, the Class 100, Class 1000, and Class 10,000 labs. So it's something we're really, really excited about. Things are moving forward, and hopefully this has been helpful for you to learn about how shared resource centers works, and maybe learn a little bit about MEMS chips and the part they play in our society today.